Hello guys, let's try and solve some problems on angles in a triangle. Here we have ABCD is a square, P is a point in the square such that PAB is an equilateral triangle. We have to find angle DPC. Now, as you guys can see the diagram, the figure isn't provided to you here. So the first part of solving this problem is to draw a diagram, and let's try and draw the diagram as cleanly and as accurately as possible, because the better the diagram, the easier it is for you to solve the problem. So let's draw the square. Here let's now name the vertices of the square. This would be A, B, C and D. Now let's try and plot point P. Now we know that PAB is an equilateral triangle, and a common mistake that the students make is they tend to plot P in the center of the square. So what happens if you plot P in the center of the square? Let's take a look. So guys, is this an equilateral triangle? It's not. You should know that for equilateral triangle the angle is 60 degrees, and this looks like it's something like 45 degrees. So you should always keep these little things in mind. So the point P, for APAB to be an equilateral triangle, point P would be a bit higher up in the triangle, in the square, so it would look something like this. Now let's go ahead and name it point P. Now let's complete the final portion. Let's draw triangle GPC. We have the figure now. The next step is to mark all the angles we know. And because ABCD is a square, the angles of the vertices of the square is 90 degrees. So angles PBC and PAD are 30 degrees. Now that we're done marking the angles, I would suggest you to pause the video and come back here once if you get stuck somewhere. Because it's always good to solve the questions by yourself rather than just watching a video. Now, because we're dealing with a square and an equilateral triangle that shares a side AB, we know that all the sides here, all the 6 sides are equal. So let's go ahead and mark all the equal sides. Now that all the equal sides have been marked, we see that triangle PAD is an isosceles triangle. And we know that for an isosceles triangle, if you know one of the angles, you can calculate all the other angles of that triangle. Now we know that these opposite angles are equal, and they can be calculated to be 75 degrees each. Now because it's a square, we know that angle ADC is 90 degrees. And this would mean that angle PDC is 15 degrees. And now because we're dealing with squares and equilateral triangles, we can call this as a symmetrical figure. Whatever is happening on the left side will be happening on the right side. So we can say that angle PCD is 15 degrees as well. And if you don't believe me, you can try solving the angles for triangle PBC just the way we did it for triangle PAD. So now we have both angles as 15 degrees. So it's pretty straightforward to calculate angle DPC, 180 minus 30, which would be the final answer, 150 degrees. So this was a fairly easy question. The more you practice, the easier this gets. All these rules will subconsciously come to you and you'll be solving them pretty fast. Let's try and solve a few more questions. So next we have a CAT question, and as you can see, the figure has been provided to us. We know that AB is equal to BD is equal to CD. Now let's mark these in the figure. We have AB, BD, CD. Let's mark them as equal. So guys, this is a fairly straightforward question. I would suggest you to pause the video, try it yourself, and then come back if you get stuck somewhere. Assume you have given it a shot. So here we have AB, BD as equal, so we can mark the angles as A. Now what can we tell about angle DBC and these two angles A? We know that these two angles add up to angle DBC because DBC is the exterior angle of triangle ABD. But even if we don't think in terms of exterior angle, we know that for triangle ABD, this angle would be 180 minus 2A. So obviously the other angle, angle DBC, would be 2A. Now for the other triangle, triangle DBC, we already know that lines DB and DC sides are equal. So we can go ahead and mark this angle C as 2A. And now, guys, this can be solved by basic trigonometry. That is, we know these two angles are 2A. We can mark this angle, angle BDC, as 180 minus 4A. But then it's like a lot of writing, and even though there's nothing wrong with it, there is a shorter and an easier method to solve this using exterior angles. So here 96 degrees, is it the exterior angle of triangle DBC, or is it for ABD, or is it the exterior angle of the entire triangle ADC? How do you figure this out? So if you're struggling with figuring out which triangle it is, all you have to check is which side is being extended. So here AD is being extended, so we know that the triangle is ADC. Once we found the triangle, we know that 96 is the exterior angle. So 96 degrees is the sum of the interior, remote interior angles, which are A and 2A. That is angle A and angle C. So we can go ahead and write 96 is equal to A plus 2A. So 96 is equal to 3A. So we have found A is equal to 32 degrees. Now remember, guys, A is not the question. The question is not to find A. We have to find angle C, which is 2A. And 2A is equal to 64. That is your final answer. So just a little thing to keep in mind. When you're solving these questions where you are like constantly working with variable A and 2A, you might solve for A and just quickly mark the answer A is equal to 32 degrees in your paper. So always keep in mind, like, never lose track of what the actual question is. In this case, it was angle C. Here we have another slightly complicated question. A, B, C, D, E is a star, and we have to find the sum of the angles of the vertices. Although there are many ways to solve this, doing it using exterior angles, if you can visualize it, would be the simplest way. And as a general rule, because we don't plan on memorizing formulas for stars and other fancy shapes, we have to always simplify the figure, right? That's how we could get good at geometry. So here in this particular question, we see many triangles. So we should instantly recognize this as a question related to triangles and proceed that way. So let's begin by marking the vertices of the triangles. We have A, B, C, D, and E. Remember, students, we are planning to solve this using exterior angles. So the first task always is determining which triangle we will be starting with, and luckily for us, we should arrive at the solution regardless of which triangle we pick first. So now let's take a look at the triangle with the vertices A and C. So what can you guys say about the exterior angle of this triangle that I have highlighted? We can say that the exterior angle is equal to the sum of A and C, right? A plus C. Now, students, let's look at the triangle with vertices B and E. Let me highlight the triangle for you in pink. So what can you say about the exterior angle of this triangle? Yes, it is the sum of the interior angles B and E. Now, if we look at the little triangle with all the angles marked, we see that angles A, B, C, D, and E add up to 180 degrees because the sum of all interior angles is obviously 180 degrees. A really nice and interesting solution, isn't it? Now, remember when I said you could start with any triangle and arrive at the same solution? So why don't we try finding out the angles of this little triangle here? Again, as an exercise, I would suggest you to pause the video, try it yourself, and come back once you have found the solution or you got stuck somewhere. I hope you guys have given it a shot. Here, this angle is the exterior angle of the triangle with vertices A and C. So this angle would be equal to A plus C. Now, which triangle should we consider to find out the other angle of this red small triangle? It is the triangle with vertices B and D. So that angle is equal to B plus D. So once more we have arrived at the same solution. You can solve it for these other triangles as well, for practice, but you should be getting the same solution for all the triangles. Here we have another cat question. It is a tricky question, but solving it using exterior angles is easy, or easier, should I say. Before getting to solving this, let me show you in a figure how to determine the interior angles when the exterior angle is given. Because I know some students struggle with visualizing the exterior and interior angles of a triangle. Here you see multiple triangles within one triangle and one extended arm. So 120 degrees is the exterior angle of which triangle? So if I draw an outline on the big triangle, you can see that when I extend its side, it does not coincide with the line of the exterior angle. So I know that 120 is not the exterior angle of the big triangle. To determine the triangle, all you have to do is follow the extended arm. Once you follow it, you realize that it is the extended arm of this small triangle here. So that means 120 degrees is the exterior angle of this shaded triangle. So if the remote interior angles were A and B, that would mean 120 degrees is equal to A plus B. Now that this is clarified, let's go back to the problem. Let's start from the right side here. We have AG is equal to FG. Let's mark that in the figure. And because AGF is an isosceles triangle, we can mark these angles as A. Then we have FG is equal to EF. Let's mark that as well. Here we know that angle CGF is the exterior angle of triangle AGF. So that would mean angle CGF is 2A, A plus A 2A. And because triangle FGE is an isosceles triangle, we know that angle FEG is 2A. Next we have DE is equal to EF. So let's mark that as well. So guys, what is angle EFD? Well, EFD is the exterior angle of triangle AEF. Here, look at this. Once I draw an outline, you see the picture, right? As always, exterior angle is the sum of remote interior angles. So it's A plus 2A, which is equal to 3A. And we know DE and EF are equal. So angle EDF is 3A as well. Let's write it down. Angle D is equal to 3A. And we know angle A is equal to A. And now we have to find angle AED. So let's try solving it from the left side. So here we have AB is equal to BC. Let's mark it in the figure. Here we see that ABC is an isosceles triangle. So angle BCA is equal to A. Following the same process, let's mark the exterior angle of triangle ABC, which would be 2A. Then we have BC is equal to CD. Again, it's an isosceles triangle. That means angle CDF is also equal to 2A. Now if we look at this big triangle ACD, which I have outlined for you, can you guys tell me what the exterior angle ECD would be? Now that we've been solving these exterior angle problems for a while, you should be instantly able to tell that the exterior angle is the sum of A and 2A, which is 3A. Now we have CD is equal to DE. Let's mark it in the figure. And again, we know CDE is an isosceles triangle, so the angle CED would be equal to 3A. So we found the third angle of the big triangle AED as 3A. Now guys, we have all the three angles E, A and D of the triangle. So their total sum 7A would be equal to 180 degrees, right? Yes. So A is equal to 180 by 7, which is the final answer. So guys, this shows that even though exterior angles or angles in general is a really easy topic, simple topic, questions can be quite confusing, right? So let's try and solve some more problems.